Dear students of class 10, before starting this chapter, let us recall the key terms associated with this chapter, whatever we have learned in earlier classes. So first of all, algebraic expression. As you know, a combination of constants and variables connected by plus, minus, into and divide signs is known as an algebraic expressions. Now, polynomial. It is an algebraic expression in which the variables involved have only non-negative integral powers. It means the variable must have positive sign. The highest index of the variable in a polynomial of one variable is called the degree of the polynomial. Dear students, as you know, we can classify polynomials with respect to degree. A polynomial of degree 1 is called linear polynomial. A polynomial of degree 2 is called quadratic polynomial. A polynomial of degree 3 is called a cubic polynomial, as you have learned in earlier class. Now let us define the zero of a polynomial. Let Px is a polynomial and a is any real number. Then if we put a at the place of variable x and if we get 0, then we can say that a as the zero of the given polynomial. Geometrical meaning of the zeros of a polynomial. In this section, we will be able to understand the geometrical representations of linear and quadratic polynomials and the geometrical meaning of their zeros. For this, let us take an example of linear polynomial. Let us consider a linear polynomial in the form of ax plus b, as you know very well, where a is not equal to 0. So we have a linear polynomial of variable x, that is 2x plus 3. Let us consider y equal to 2x plus 3, and as we take the value of x as 1, minus 1 and minus 2, we get the value of y as 5, 1 and minus 1 respectively. When we plot these points on the graph paper to represent this polynomial geometrically, we can see that the line intersect the x-axis at minus 3 by 2, as you can see on the right side of your screen. As you know that the zero of the polynomial 2x plus 3, whatever we have taken, is minus 3 by 2. So we can conclude that a linear polynomial can be represented by a line, and that line must intersect the x-axis at exactly one point. Now let us have a quick view of the geometrical meaning of the zeros of a quadratic polynomial. For this, let us take an example of a polynomial of variable x, as you can see on the screen, that is x square minus 3x minus 4. To see how the graph of this polynomial look like, let us consider y as x square minus 3x minus 4, and we put the respective values of x and we'll get the value of y, as you can see on the screen. Now if we locate these points above on the graph paper and draw the graph, it will look like curves, and these curves are called parabolas. As we can see that the parabola intersects the x-axis at exactly 2 points, that is minus 1 and 4. We also know that there are two zeros of a quadratic polynomial. So here are the two zeros, that is minus 1 and 4, as the graph intersects the x-axis at these 2 points. Now, dear students, we can conclude that the number of times the graph intersects the x-axis, that represents the number of zeros that a polynomial have. Now we are in position to start the first exercise of this chapter. Exercise 2.1. Here are the graphs of some polynomials of variable x, and we have to find the number of zeros. As we know that the number of zeros of a polynomial depends on the number of times the graph intersects the x-axis. First graph does not intersect x-axis anywhere, so the number of zeros is 0. In the second graph, we can see that it intersects the x-axis at 1 point, so the number of zeros will be 1. Similarly, the third graph intersects the x-axis at 3 points, so the number of zeros will be 3. In the next graph, we can see that it intersects the x-axis at 2 points, so the number of zeros will be 2. Similarly, in the fifth graph, we can see that it intersects the x-axis at 4 points, so the number of zeros will be 4. And in the last graph, it intersects the x-axis at 3 points, so the number of zeros will be 3. In the next video, we will learn about to establish the relationship between zeros and the coefficients of a polynomial. Till then, keep learning.